Alright, we're going to keep going with radicals here. We're going to add and subtract them this week. We'll multiply and divide them next week and kind of see where we end up. So big thing you need to know here is in order to add and subtract radicals, you need the same number underneath the radical. So with that said, you're going to have to simplify radicals. Think about what we did last week. And we're going to then just add or subtract the two terms. That's it. So I got 6 examples for you. First 2 will go by pretty quick. Next 4 after that, nothing crazy either, but 6 examples. Let's go. Alright, notice with these two, they already have the same thing underneath the radical. Alright, first one has a 2, 2, 7, 7 underneath the radical. Let's just focus on the first one now. So all we're doing here is we are just adding the numbers that are out front. We don't touch what's inside the radical once they're simplified. Once they're the same, we don't touch them. So we just literally add 5 plus 7, we get 12, and it's 12 radical 2. Simple as that. Next one, same deal. Both are the same thing. We just subtract 12 minus 18 is negative 6. Radical 7 stays underneath. When they're the same, simple as that. Our goal is to get these radicals to be the same. So let's check this out. We have 2 radical 18 and plus 4 radical 2. Now, if we look, the radicals are not the same. We have to get them the same. The first radical can simplify, but the second one cannot. So our goal is to get a 2 underneath the radical. So you think to yourself, what times 2 gets you 18? Well, it's 9. 9 is a perfect square. This is what we did last week, this left side. Square root of 9 is 3. So we have 2 times 3, which becomes 6. 6 radical 2 plus 4 radical 2, we get 10 radical 2, just like we got in the last slide, something like that. Alright, I have some notes down the side of basically what I'm saying to you anyways. Another example similar to what we just did. Radical 3 is underneath radical 12. Radical 3 can't be touched. There's no other factors of it. 12 can be though. So I just switch it up a little bit. I have subtraction this time too. We think to ourselves, what times 3 gets you 12? It's 4. 4 is a perfect square. We're good. Square root of 4 is 2, so we do 5 times 2. Negative 5 times 2 is minus 10. So we do 11 minus 10 after that. We get 1 radical 3, or just radical 3. I don't care which one you write. Both are correct. Absolutely correct. You choose. 2 more. We have to simplify both of these on this one. Now, the first couple I'm giving you, or the first one I'm giving you, there'll be a couple examples like this on the worksheet as well. The numbers underneath are perfect squares. You can simplify both, but they're both already perfect squares. Square root of 36 is 6. Square root of 25 is 5. So write that. Multiply each term. 3 times 6 is 18. 4 times 5 is 20. So 18 minus 20, negative 2. No radicals left over in this one. Alright? So hopefully nothing crazy there. Last one. We do have to simplify both. You can simplify them one at a time. You can do them both at the same time, whatever you want. I'm showing both at the same time. So we have to think, to break down these radicals, we have to think about what factor of 32 is a perfect square. Well, it's 16. What's the biggest factor of 32 that's a perfect square is 16. The biggest factor of 50 is 25. That's a perfect square. Look at both of these underneath the radical. There's a 2 left underneath the radical here. So you have 2 times 4 times radical 2 plus 5 times radical 2. So we get 8 radical 2 plus 5 radical 2. Final answer is 13 radical 2. Alright. You have a worksheet. I believe it's 12 problems. You have 3 problems like examples 1 and 2. 3 problems like examples 3 and 4. 3 problems that are like example 5. 3 problems that are like example 6 here, and that's it. All right, have a good week, guys.